Hello. Awesome. So welcome everyone to the demo. So Skarbek, you have the first item.
Indeed. So I created a change request that allows me to, without following a pre-described script, make specific changes to the API and our ability to tune it to see if we can make any improvements or accidentally degrade things. Luckily, so far, we haven't created any degradation, but I'm actually kind of at a loss as to how to proceed forward because I feel like I've made improvements, but it's harder to actually visually see those. So I'll first go through what I changed so far, and then I'll show some charts as well. So, um, so firstly, this was cluster B that we're modifying, and it was already slightly configured differently than the rest of our clusters. So number one item is the amount of our HPA tuning was at a value of 2600 versus the
We can't
default.
see. Are we meant to be able to see?
I'm not showing anything yet.
Okay.
Um, sorry, just wanted to give a quick highlight. And then we also have a worker count difference. In this case, we have it configured to 6 versus the standard 4 on the rest of our clusters. So the first change I did was to modify, let me now share my screen. We changed the amount of CPU requests or HPA average CPU requests. So we tuned it closer to the value of the amount of workers that were running. So instead of 2,600 or 2,300, I believe. What was it before? It was 2,600. We bumped it up to 3,000 with the intention that we would end up removing some pods from rotation, which did occur. We also saw Ruby thread contention bump up a little bit, which was expected. But the aptx didn't change. We do have these awkward periodic drops that happen quite frequently, but we can see that cluster B is the red line. I should have put the legend here. Cluster B is the red line. We can see it's actually higher than the rest of the clusters, which is a good thing. So we're actually doing pretty good. Memory saturation was still high that I wanted to address. And that's exactly what I did next was move our existing limit from 7 gigs and bumped it up to 10 gigabytes, which should put us around 70% usage. In this case, we went from hovering around 85% and we dropped all the way down to 55% RAM usage. So I thought that was great. So we're making progress, but we haven't made any end goal progress towards lowering the amount of pods and nodes that are being utilized just yet. Pods a little bit, but not enough technically. So the next thing I did was modify our HP again. In this case, I'm trying to squeeze a few more workload onto the existing number of pods. So we changed the target average utilization from 3,000 and bumped it up to 4,000. So this is currently equal to the amount of CPU that we request, which is still lower than the amount of workers that we run. And with that, I noticed that the CPU saturation for the nodes that were running more pods than say one pod, we saw CPU saturation of those nodes increase, which is what we want to see. This chart is showing roughly 60% CPU utilization, but we had a lot of nodes only running one pod. So it's harder to actually see any progress because it takes the cluster autoscaler, from what I've seen, approximately 15 minutes before it decides to add or remove nodes in general. So a lot of these nodes where we're running only run pod, eventually they'll get cleaned up, but it appears the cluster autoscaler is kind of sluggish at that point. So I'm kind of disappointed by that. But the one thing I did want to highlight was that the Ruby thread contention jumped right back up to just shy of 80%. So I don't really want to modify that any further. But our pod counts are a lot lower. So here, or excuse me, pod counts. Yeah, we were running like 37 pods. We're down to we're running 30 as of right now. But like our nodes, they jumped when we had to deploy. And they just been slowly trickling down. Like the time between these two events is about 15 minutes. So I don't think we'll actually see the usefulness of this experiment because it takes so long for the nodes to spool down. Um, in an effort to see if I can't jumpstart that process, I was watching our memory saturation and it had jumped up to 80% again. I thought, let's try to get that down again. And because that's going to cause a rotation of all the pods due to that configuration change, maybe that'll recompact things. That way we potentially have no pods running on some of our nodes. And then maybe the cluster autoscaler will get rid of stuff pretty quickly. So that was the last thing I did. That was about 20 minutes ago. And that's where I'm at now. And after doing a bit of math, we were running 192 workers for the API service in each zone prior to us moving to Kubernetes. At this moment in time, we're running 240 workers. So we're running 20% more workers now than we were previously. And I actually think that's an okay value because we were slightly under provisioned in the API service prior to this migration into Kubernetes. So I think from a worker count standpoint, we're okay. From a node pool standpoint, I'm probably not going to see a lower node count until a larger amount of time has passed, just due to the amount of nodes that are running just one pod. And the cluster autoscaler just taking an obnoxiously long time to remove nodes from the cluster. So like it just removed one a second ago. So I kind of want to keep this experiment going. I'm weary of changing any values related to CPU and the HP at the moment because our Ruby thread contention is right back up to 80%. The unfortunate thing that I'm not entirely amused with right now is that the HPA target and the amount of CPU that we are requesting is the same value, which
Yeah,
means our
I don't
Go
like
ahead.
this really. Yeah, having the HPA target and the request at the same value means that we constantly will have pods going over and below, and especially going over isn't really nice. On one hand, because I plan to have saturation metrics in this, and every time we are oversaturated, it's not nice looking in the graphs, right? And the average is an average; it's not a maximum, right? So I think we should at least have it the request slightly higher than the average, so that we fit most of it below it, maybe.
Yeah.
I think that would be better. I mean, if we sometimes have pods going over, we can't do much about it, I think, because there's always a lot of variance in CPU usage.
Yep.
Yeah, but I think we should not have it equal. And to the other point for seeing nodes going down, I think where we can get forward here is now only to see if we can fit pods as good as we can on nodes, right? Like leaving just a little bit of allocatable resources over if we fit, let's say, 2 or 3 pods on each node. I think more efficiency can only be gained if we maybe have bigger pods, which exactly are matching on the nodes, maybe.
But we can't increase the size of CPU requests because otherwise we can no longer squeeze any more pods onto the nodes because we're pretty much at that limitation of what Kubernetes will allow us to schedule per node as it is. So from my perspective, our best idea at this point is to increase the amount of CPUs that we have allocated to this node pool, which we cannot do for the C2 instance type without jumping up a large amount of RAM, which is only going to increase cost tremendously. And I don't think that's a wise choice. Our best bet would be to switch to a different instance type, but we chose C2 for a reason. I have to go back to figure out why we chose C2. But as far as I know, their clock speed is a lot faster. Unfortunately, this particular CPU or this instance type doesn't have as much flexibility in terms of customization, unfortunately.
But with the 4000 requested CPU, I think we can fit 3 pods on each node, right?
At 4000, yeah, it's like 3.04.
Yeah. So
which is actually really nice because hopefully for the nodes that are only running one pod, when a deploy occurs, there's less nodes that need to be scaled upward in order to get new pods into place during a deployment, which speeds up deployments by a little bit. But
I
again,
was wondering what would happen if we increase the pod size to, I don't know, 5,000 or 6,000 requests, and so that we exactly fit 2 pods on one node.
we could do
With
that,
a
yeah.
much higher amount of workers, maybe, to see if that even helps more.
That's a perfectly legitimate item that I was considering, because right now we're not seeing any more than 2 pods anyways. At 4,800 requests, which puts us right around 80% of the HPA target average value, that'll give us 2.6 pods per node, which we're not going to ever see. So I think that would be a fine change that I might do next.
Yeah, but if you say we don't see more than 2 pods on nodes anyway, maybe it's Kubernetes is, if you scale up, right, then we fill nodes with pods, and then later traffic drops down, and then we remove pods from nodes, but we don't remove nodes very fast, right? It takes a long time. Yeah. So we will run for a long time with not really filled up nodes. And if you just have two pods on each node, then the effect will be even worse, because then we will have just 1 pod maybe on a single node.
Yeah, which we don't want to do unless I spin up the
Yeah.
amount of workers tremendously. So yeah, I'm not entirely pleased with this experiment thus far. Like there is some progress, but it just doesn't show up as quickly as I kind of was hoping for, unfortunately. So
why does it take so long for things to be cleaned up? What's that 15 minutes coming from?
GKE does not specify how often their cluster autoscaler does any sort of evaluation in their documentation. So I'm not actually sure.
I think that they are also considering the fact that spinning up a node is an expensive operation, because you cannot, until it's fully provisioned, you cannot utilize it. So maybe it's a kind of the bouncing of spikes, because you may have a spike of traffic, you increase the number of machine, then it goes down, maybe just go down because you are not allowed to serve stuff, right? So, and then it goes up again and you just destroy the machine and you need to recreate from scratch.
So the 15-minute window that
I see, build by minutes, so
so the 15-minute window that I see is just from our metrics. I'd have to go, which I haven't done yet, look at our logs to see if maybe they're evaluating more often, and I just haven't seen the results of those changes. So I'll be looking into that during the rest of this experiment as well. So yeah, that's where I stand currently for this interesting experiment. I'm just glad I got the change request approved, because it's not one that's kind of standard policy. So I'm happy about that.
Can I do a very naive observation based on my understanding of what is happening? So it sounds to me that basically we have those boxes and we want to fit football balls inside it. And basically there's a lot of empty unused space. And the problem is that we have just one size of balls instead of having, which is more so if you look at all the commercial around Docker and Kubernetes is very designed for having different size and type of workload, so that you can just put everything together and they kind of naturally squeeze together. So you're kind of filling the empty spots, right? So you have a better optimization of traffic. But we have just one size, because kind of it's just one single application. And so all the pods are more or less same amount of resources, same size, same CPU requests. And so you can fit 1, maybe 2, but then does it make sense? I mean,
that's actually a perfect analogy. We've got the footballs are the API pods, whereas the ping pong balls are, say, the supporting services required by Kubernetes to run on these nodes. Everything is filled with air, so they're compressible. But in terms of being able to squeeze another football in, you can't, because you just can't shove another item into that box. It's full. The limits is where we would end up seeing the compression of those footballs. That's where the football can't be expanded to its full capacity, because the node might be running under high contention or CPU load. but we're trying to stay under a certain threshold to make sure that our nodes are not being thrashed in any way. At the same time, making sure they're not going to thrash our actual pods and the workloads and negatively impact the aptx. So, yeah.
We need some memory-intensive workload with a very low CPU request, so that you can kind of bump the machine and just not waste all the memory.
Yeah, like what we have here is the API is just very CPU intensive, and the nodes that we're using have a lot more memory allocated versus the amount of CPU that we kind of need. So realistically, I think the ultimate solution here is to modify the CPU or the instance type that we utilize. I just need to go back to the history to figure out why we switched to C2s, because I know that was a project in of itself. So I think what I'm going to try to do is finish up this experiment first and then explore that route if necessary.
We switched to C2s because we found we were very CPU bound and on the API, and it was more cost efficient to do C2s. And in fact, it was started out as a performance thing where just by switching to C2s, we were getting a lot more performance out of the API.
Yeah. Okay.
And do you have an idea, Skarbek, of what like good enough will look like?
Well, I actually documented this in the change request that I'm looking to reduce the amount of nodes that we run down to 15. Currently, all I've done was increase the amount of nodes that we're running. So I've done the complete opposite of my goal here.
And with the other, what was the previous thing we migrated that was also under provision before we migrated it? Can you remember? Was it k8s? There was something we previously migrated that was also really under provisioned, and we had trouble tuning that down. I'm wondering what we ended up with on that one, like how close we managed to hit it in the end, because it wouldn't have been like for like, right? Because we knew we were under provisioned.
I wonder if that was the registry or the first one that we migrated.
No, I think it was later. What was the one that delayed us as we moved into Q4? We spent a lot of time through this November tuning.
It would have either been git SSH, which maybe the GitLab shell.
Maybe, yeah. It might be worth having a look at. I'll see if I can actually find it.
Well, Henry's tuning the shell currently, so I'm not actually sure. But also keep in mind that when we first migrated all these services over, we didn't really spend a lot of time afterwards. Like this is the first migration where we're spending a lot of time afterwards tuning these values after the fact. We haven't done this for any other workload, which is what Henry is currently doing.
Awesome, sounds good. It's a nice segue there. Have you got any demos, Henry?
I can talk about what I found at least for tuning. So not really demoing much on that, but the basic things, I was looking to observability and what metrics are missing in Kubernetes. And I noticed that for a lot of these saturation metrics that we got before in the VM fleet, we now need to do it differently because we can either measure saturation against set limits in Kubernetes, like CPU limits and memory limits, which is what we do until now. But for certain deployments like API, for instance, we don't have set CPU limits, so we can't measure anything. And the other thing is measuring saturation against the requests that we use to reserve space on the nodes, which is also determining how Kubernetes is scheduling pods and then trying to find place for them. And by trying to find a saturation metric for a base on requests for CPU, I found that for a lot of our deployments, we are totally oversaturated. And that's especially true for Sidekick, GitLab shell, and also for registry a little bit. And so we need to adjust there. And for GitLab shell, that's a lot of work because for each single shard, we need to adjust the settings there, maybe see how it reacts and how it we'll play with that. I mean, it's all working fine right now. I mean, we didn't run into any big problems, but what we already saw in Sidekick is the strange issues with HPA node saturation, right? Where we're running at 100% saturation of the node pool, but still don't seem to be having aptx issues. And I'm wondering if this is related to setting requests in the wrong way. So by adjusting those, we will see maybe more usage of nodes for those deployments, but we should be safe on not running into a situation where we are out of resources because we planned wrongly and set the wrong requests in Kubernetes. That's what I'm working on currently. Like, I'm not working on that. I'm making issues for that. I just also made 2 MRs for registry in GitLab shell already, but for Sidekick, that would be, I don't know, 10 MRs to work on. So that's just an issue that I created with some suggestions on how to work on that. They're all put into this epic I created for this, which is linked here. Yeah, and this is currently blocking my saturation metrics work a little bit because if you don't fix this, then the saturation metric, as soon as we enable it, will cause alerts. And then we would need to silence all of those and fix it later. So yeah, we need to see how we work with this. If you find time fixing this, that would be great. Else there's still enough work to work on other observability issues for Kubernetes, so I can work on that. And this can wait a little bit.
Does this overlap with the taint work, the other epic we have?
I don't think so. Besides that, having better observability on where we are saturated certainly would help, I guess. But it shouldn't have a lot of overlap. Tainting is just to determine on which nodes we have certain pods running, right? Which we don't do for some of the kinds of pods that we have, like most of the logging and monitoring things, I think.
Yeah,
right?
The taints work is more geared towards the scheduling of what pods run where. And while I guess the overlap comes in, how we schedule our workloads, but for the most part, we've been trying to segregate our workloads on their own node pools. And we've got some workloads that shouldn't be running where they do. Primarily the monitoring stack is running on certain node pools that we don't want them to. And I think I'm pretty sure that's the overall goal of that epic, but I'd have to re-review it.
I mean, one thing that would be helpful for that is having a saturation metric for how many requests are we already using on a node, right? I'm not sure if we have those anywhere. I wanted to look into that next. Because if we see that which node is having allocated how many requests already, then it's much easier to see where we could fit in more pods or where we are inefficiently using nodes. And I think that would be a helpful metric also for looking into how we taint things. But they're not closely related. You can figure this out by looking into the GCP console or other ways. It's just a little bit, it's not in a nice place to figure this out. I need to work a lot with Thanos and GCP console. Mm-hmm. But we should be able to get this into a Grafana dashboard, I think.
And are you making these changes to registry and GitLab shell and Sidekick? Is that, or are you to unblock the saturation?
I created those MRs because they were easy and fast, but I didn't execute them because Skarbek was working on Kubernetes right now. But they can be executed anytime when we feel fit for that.
Okay, so your plan is to finish the stuff to get the saturation metrics unblocked?
No, because for GitLab shell and registry, that can be done. It's not too much work, but for Sidekick, that's a lot of work. Because for each single shard, we need to find the right values. And most of them are tuned in the wrong way for memory and CPU. And this is just work to be done, but this, I don't know, that would take a while to get this all finished.
Is it possible to get saturation metrics for everything except for Sidekick?
Yeah, I mean, the way to do this would be to just enable it and then silence alerts for Sidekick, for instance, for saturation metrics on Sidekick. I mean, it's not hard to do. and then we can
What are
aim
your
for fixing
thoughts
this
on
later.
that, Jav Skarbek, like on having something that we are silencing an alert just because we haven't done the work to make it not go off, basically?
If we could configure the alert disablement inside of our like configuration, I think that would be a wise choice just until we get the work completed. Because it's not worth our time to create an alert if it's not going to be useful. And it's just more work for the SRE team to create the silence and reestablish that silence until we complete that work.
Yeah, the thing is, while we are tuning, of course, the metrics are useful, right? If you see that we are saturating requests, then we know that we need to tune here, right? So it's very helpful to have these metrics and to look at them. And if you can just, for the 3 deployments, registry, GitLab shell, and Sidekick, disable the alerting, then we still can see how we do in API and the other services, right? So that was the idea.
Okay. Okay, yeah, let's make sure something's moving forwards. Either like we push on and get the saturation metrics so that they can be used, or if we aren't in a place where we can do this, let's be clear and like park this stuff and move on to some of the other observability work. So Graham is making good progress on the web migration. So like, let's focus on doing what we need to improve observability for web migration so that that goes a bit easier.
Yeah.
Cool. Okay. Sorry, Scott, I also skipped over your point in that point. So let's talk about your theory, aptx drops.
So we have been seeing aptx periodically drop anytime there's a deploy across all of our clusters for the API service. And this might happen to other services, but API is the one that we notice because that's the one that we're focusing a lot of our time on right now. I was pairing with Henry earlier this morning and we watched the production deploy go out. And I've got a theory where we are using our default rolling strategy for deployment. And the default strategy provides you with a max surge of 25%. What that means is that if you have 100 pods, it'll add at most 25 pods during the replacement period. We also have a max unavailable set to 25%. Those are the defaults provided with Kubernetes. And what that particular value means is that during a deploy, at most 25 pods will go start their termination procedures, at what point they'll stop taking traffic. So we'll go from 100 pods that are in operation down to about 75, which will continue taking traffic during the time in which deployment is occurring. And the pods will get rotated. So as a new fresh pod comes online, and one will be torn down. So my theory is that I think we're dropping the amount of capacity we have an unnecessary amount during a deploy. We could toy with these values, but last time I checked, our Helm chart doesn't allow us to adjust these values. Kubernetes allows us to toy with them. Our Helm chart possibly does not. I think for our smaller environments, that being Canary and staging and such, it might be worth toying with these values if possible to potentially figure out if maybe increasing max surge to a higher value, that way more pods spin up, and lowering the amount of pods that get torn down during a deployment process. That way we could get it as close as possible to the same amount of pods taking traffic before and after a deploy. But this last time I checked, this requires a Helm chart update to add that capability. This is just a theory at the moment. Obviously, I think the only way to really prove this is to really dig into our logs, which will be a little time consuming because we have to cross-check the logs between the events of Kubernetes and the events of when a pod stops and starts taking traffic throughout a deployment cycle, which is not an easy task to do. I plan on creating an issue for this. I just haven't yet because I've been working on this change request.
Awesome. Yeah, it sounds like a good one. Yeah, it'd be interesting to test that. How difficult would it be to put this in the Helm chart and just play around with it? And if it doesn't do anything, just take it back out?
Oh, this is one of those things where I think anyone could benefit. So if we put in the Helm chart, leave it there. But this should not be a difficult add to our Helm chart. We would follow the same commonality we could follow the same pattern that we have in other locations to add this capability. I would start with our web services chart, and if we identify stuff like this is happening kind of badly through other services, we can certainly take it over to our other individual charts as well.
Cool. Yeah, it sounds like a really good one to test out. That would be, that sounds like it'd be a really good thing to try and settle
I don't
down.
want to say that this is a web blocker, but I think we need to be careful that during deployments, just keep an eye on the aptx, and if it does unnecessarily breach our SLOs, we probably should bump the priority of this issue.
Yeah, that's a good point.
I mean, that already becomes an issue if we tune API first on Canary, right? Then usually it shows very big aptx drops where in gprod we don't see it. So we can't use the same values for tuning, or we need to choose different values for the maximum search in Canary. Canary will always suffer during
We do
deployments.
have a workaround for this in the meantime, where we could just simply increase the minimum number of pods.
Yeah, I think that is
small
what we did last time, right? Yeah.
Yeah.
Nice.
Cool.
Yeah, sounds good.
The only last thing I wanted to make comment on is, and this will probably impact Henry the most, but I did want to comment that we did yesterday introduce a new shard. It's simply called imports. The only worker that's on it is the repository import worker. The reason for this new shard is it's been identified that we sometimes will kill a pod while an import is happening. And for imports that take a lengthy period of time, that import might get killed. It'll get picked up by a new scikit worker, and then some other scaling event occurs and kills that pod. So then that job ends up having to be requeued again and again and again. So what we're doing with this particular shard is not allowing it to scale in any way, shape, or form. It's just going to stay at a static node count forever. This was just introduced yesterday, and I need to still pull off the repository worker from the old catch-all shard. And then we also need to make sure I've got enough pods running. That way imports don't get seemingly hung. Right now, there's only 4 pods that are servicing this work. I suspect that's not going to be enough, but I'm going to try to complete an evaluation of that, bump the workers as necessary, as well as removing imports from the old catch-all shard.
But during deployments, it's will still restart pods, right?
Oh yeah, deployments we will still see impact regardless, but auto scaling is where we see the greatest impact, because that happens very frequently, especially with scikit, because our HPA is very sensitive. So
do we see the same with exports too? Because exports also are very long.
Probably. But that's also tied to the memory bound shard. And I think just the workload characteristics of that entire shard varies quite drastically compared to catch-all.
Nice. Thanks for dealing with that one, Skarbek. Do you know, like, sort of how long do you think it'll be before we know if we've got enough resources for that, or whether we have to scale?
I'm going to try to complete that evaluation today. It's not entirely easy just due to the nature of the way work works, and release management is kind of a little busy these days. But aside from that, I'm hoping to try to complete that today.
Awesome.
If not, I'm bad at saying this, I should probably say by the end of the week.
After 14.0, right?
Yeah.
Awesome. That sounds good. Do you need any help with any of these things?
No, like this one's going pretty smoothly. It's just a matter of getting the work done.
Cool. Okay, sounds good. And Henry, I should have asked you the same. Do you need any help with any of your stuff you're working on?
No, I'm not blocked. I just need to figure out how to best bring those metrics together. It's a little bit fiddly for the stuff I'm working on. Need to reach out to experts like Andrew, maybe, if I get stuck.
Cool. Sounds good. Great. Was there anything else anyone wanted to discuss or demo? Nope. Okay. Awesome. Just as a kind of update, so Graham is working on putting together a setup for Nginx that will allow API and web to both run. He's also going to check that the setup he comes up with will support pages as well, and like all of the things will just plug into that. So he's going to work on that in the next few days, and then hopefully right after 14.0 he'll have something he can put onto pre, and we can actually then see what it looks like, and he'll do like a side-by-side like comparison with existing setup. So hopefully the web stuff is will start to become visible in the next week or so. Super. All right. Thank you very much, everyone. Really great to see everything. I hope you all have a good rest of your day. Take care.
Bye.